Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Taibono Discovery Center. And remember our WhatsApp number 079 578 2908. I'm repeating it, grade 12s 079 578 2908. You are more than welcome to send your clarity seeking questions to that particular number or any alternative method that you want to share with us. Okay, let's go straight to the business of the day. Our topics for today, we are going to look at the functions and graphs together with finance, growth, and decay. And then now with functions and graph, this is paper 1 topic, of which is worth 35 plus minus 3 marks on your paper 1 exam out of 150 marks. That is a lot, grade 12. 35 marks of 150, that will be your functions and graphs. After the completion of the lesson under functions and graphs, you will be able to work with relationships between variables in terms of numerical, graphical, verbal, and symbolic representation of functions and convert flexibility between these representations. That means in terms of tables, graphs, words, and formulae. And then you will be able to determine the effect of the parameter which results in vertical or horizontal shift, that which results in a vertical or horizontal stretch or reflection about the x and y axis. And then you will be also able to deduce the equation of the graphs if critical points are given. Or you will be able to sketch the graph using tables and calculate critical points to the particular sketch or graph. Lastly, you will be able to identify the domain, the range, the axis of symmetry, and the asymptote for all your prescribed functions. And then which are the prescribed functions, grade 12? Number 1, we are having a linear graph. Secondly, quadratic function. Sometimes we call it a parabola. The linear graph, we sometimes say a straight line. It's one and the same thing. Hyperbola, exponential function, the circle and the semicircle. Semi means half, therefore it's half of your circle. Now with the linear graph or the straight line function, our original equation is y equal to mx plus c, or alternatively we can use y minus y1 equal to m into x minus x1. Remember, this m indicates the gradient of the function. Okay, and then now with the quadratic function or a parabola, the original equations, we have two of them that we are referring to. The first one is y equal to a into x plus p close bracket squared plus q. Or it is indicated by y equal to ax squared plus bx plus c. Those are the two original equation presentation for the quadratic function or your parabola graph. With the hyperbola function, we have only one original equation that we are relying on. That is y is equal to a over x plus q. And then with the exponential functions, we are having the original y is equals to a times b to the power x plus q, where your a must not be equal to 0. Because the minute this a becomes 0, is going to affect the whole exponential. You will end up not having an exponential equation. And then the b value must always be greater than 0. That means it must be a positive value for b always. And then this b must not be equals to 1. It can be any positive value except 1 greater. And then with the circle original, we are having what we used to call Pythagoras theorem. It's exactly the same formula, x squared plus y squared equal to r squared. Or alternatively, with the full circle, we can write it as y is equal to plus minus the square root of r squared minus x squared. What actually happened there, we took our original x squared, r squared equal to x squared plus y squared. And then now we want to make y subject of the formula. We are going to transpose the x squared to the left hand side, and then it becomes minus x squared equals to the y squared, and then the y loses an exponent to there, and then this side will gain plus minus the square root of the r squared minus x squared equals to the y. That is why we are saying these two equations are exactly the same for the full circle with different notation though. And then the semicircle now, we are having y is equal to plus square root of r squared minus x squared, or the y equal to minus the square root of r squared minus x squared. With the y equal to, if it is positive, it simply means now you'll be having a semicircle but on the positive y value, cutting on the positive y value. And then if it is negative now, it will be a semicircle cutting on the negative y values. And then now grade 12, let's clear the confusion about this. Remember now with the quadratic function, if your shape is concave up, meaning it's a positive function, that means the value of a need to be positive. But now with the circle, look at that. If it is positive, it is cutting on the negative. It's like facing half semicircle, facing downward. And then now, remember with the quadratic or parabola, if it is concave down, that means it's negative. Your a value will be less than 0 for that one, whereas for this is a greater than 0. So do not confuse the two grade 12. You must know now if it's a circle, semicircle, with y equal to positive, it will cut on the positive y. If it's a semicircle, y equal to negative, that means it will cut on the negative y values. Now let's start with the graphs. Now we are looking at the first one, which is the exponential function there, the activity. We are given function k, which is defined by kx is equal to 1/3 to the power x minus 9. And then now different notation for this one, grade 12, they can also write it as k into x, and then write this 1/3 as 3 to the power negative 1. Do you still remember your exponential rules? Minus 9, we are applying that now. And then this will end up being 3 to the power minus x minus 9. So this is the same graph as this one. So it can be noted as a fraction, or they can write it as 3 to the power minus x is 1, and the same thing grade 12. And then now 1.1, we are expected to write down the equation of the asymptote of k. The minute the question states that write down, that means your answer is already on the given information. So now we are looking at the equation of the asymptote of k. And then if you look at this, we are having the y asymptote. Remember, the exponential function is having only one asymptote, grade 12. Only one. Hyperbola is the one that is having two asymptotes. But with exponential, we are having only one, which is the horizontal asymptote. Okay? And then in this case, now since it's an horizontal one, it is cutting the y line. So it's a horizontal one, is cutting the y line. If you are having maybe your Cartesian y axis there, and then now you have a line that is cutting at, let's say you are having minus 9 on y there, and then there's a line cutting there. This line is called line y equal to minus 9 because it is cutting what? The y axis there. And then it is a horizontal line or asymptote in this case for this specific graph that we are talking to now. Now write down the equation of the asymptote of k. Remember we said we are only having the horizontal for exponential. Therefore, remember this k at x, it is representing y. So this will be y equal to your minus 9 there. That's it, grade 12. The horizontal asymptote or the equation of the asymptote of this exponential is y equal to minus 9. That is why it is only with 1 mark there. Second activity, you are still given the same on the same function k at x equal to 1/3 to the power x minus 9, which can be noted as 3 to the power minus x minus 9. It's one and the same thing. Determine the x-intercept and the y-intercept of k, of the graph that is given to us. We know the method doesn't change in all the graphs. Grade 12, if you are looking at the x-intercept, you let y equal to 0. So we are going to take our function there, where we are having y. Remember we said this k at x represent y. So that will be 0 on the y side equals to the 1/3 to the power x minus 9. And then now we transpose the minus 9 to the left, is becoming positive 9. Remember we said this can be written as 3 to the power minus x, is one and the same thing. And then now this 9 we are now applying the exponential equation rule. We need to make sure that both sides you are having the same base so that you can equalize your exponents. So now we are having a 9 on the left hand side. You are going to write it as a prime base 3 to the power 2 there. And then right hand side you have 3 to the power minus x. Since we are having same bases there, we can now equalize the exponent. Therefore, x will be equal to a minus x. Eventually, our x will be negative 2. Okay? And then now we look at the y-intercept. When x is equals to 0 now, on the same formula, y is equals to 1/3 to the power x minus 9. We are now substituting an x with the 0 minus 9. Any number to the power 0, those are the rules of your exponents, grade 12. That will be 1 minus 9. You can test and verify, use your calculator. Then 1 minus 9 will be a minus 8, grade 12. So that is how we calculate our x and y intercept. And this question worth 4 marks. 1 mark will be for substituting a 0 there and the final x value minus 2, for substitution of 0 for the final y value being minus 8. So this is basically 4 marks. And then continue now 1.3 on the same activity. Sketch the graph of k. Clearly show the intercept with the axis and the asymptote. Remember we said this can be written as 3 to the power minus x minus 9. You can predict your graph, grade 12, by just looking at this part here. This is saying your x is negative and your y is positive there. That means now the shape of this graph, the expected shape for this particular graph, it's where your x is negative and then your y being positive. That means your arm will be up in that quadrant, moving like that, sliding down. That is the expected shape for this particular graph, according to the prediction by just looking at the equation, right? And then now, remember we have done our calculations. We have calculated the x-intercept and the y-intercept, and then we have also identified the asymptote of this shape on the previous questions. And then we are using those calculations now to sketch this particular graph. Remember we said the asymptote will be at y equal to minus 9. We are having our asymptote there at minus 9. And then we have the x-intercept at minus 2. It's an intercept, is on the x-axis, grade 12. it must be on the x-axis because it is an intercept. And then now we are having the y-intercept being -8. Because it's an intercept, it must be on the y-axis, and then that is m-8. Remember, we have already predicted the graph that we are looking for. So this graph will come this way, cut the intercept x at -2, the y at -8, and then come closer to the asymptote, but it will never touch this line because it is the asymptote of that particular graph. Your graphs will never touch the asymptote line. So now this is allocated 3 marks. 1 mark will be for the asymptote, 1 mark for the shape, and then 1 mark for both your intercept. In order to get this mark, grade 12, both your intercept must be correct, being x equal to -2 and the y equals to a -8. That is how we allocate that 3 marks. Right, 1.4. Given function k, still using the KLX function, write down the range of k. Remember, we have already sketched our graph. Let us bring that graph here. And then with an asymptote at -9, the graph cutting at -8, and also at -2 for the x-intercept. So this is basically the graph that we have sketched in 1.3, coming closer to the asymptote without cutting the asymptote. Now, they say write down the range. When we talk to range, we talk y values that lie on that particular function. And then if you have the type, you look at the type of graph that we are having, it is above the asymptote, which cuts at minus. There is no way that you can have that graph below -9, okay? It will only appear above the -9. So now we want to identify the y values that lie on the function. So if you move horizontal there, that's immediately -8, and then you move your ruler up to 12, you see that you touch the graph throughout all the y values moving up there. And then there's an arrow that shows that this graph continues up to the positive infinities of your y values. So for that case now, we are going to say, because if we are ranging, we are talking to the y values, we are going to say y will be greater than -9. Can we say y greater than or equal to -9? No, we cannot put an equal sign because at -9, this graph is an asymptote. There is no way that we can have a graph at that point or touching that particular point. So now this will only be y greater than -9. Or we have another notation if you don't want to use that one. Okay, we can write this as y is an element of starting from -9. Remember, you need to start from the smaller value -9. You can't use a square bracket because that is excluded. And then up to the positive infinity of your y values. Infinity also uses a round bracket, grade 12s. And then now let's look at 1.5. May you try to answer that one for 2 minutes. 1.5. Try to answer 2 minutes starting now. Okay, grade 12, let's see how far did it go. Remember our WhatsApp number 079 578 2908. You are more than welcome to send your clarity seeking question to that particular number. Right, we are still using the same graph, K at X, and then we need to describe, explain the transformation of K to G. And then now what is G? G is G at X equal to 3X minus 4. So we are transforming from K at X. What is K at X? K at X, remember, if you change that notation to the 3 to the power minus X minus 9. I am bringing it closer to this one so that you can compare and see where was the change implemented on K to create a G. If we compare now the first part, the 3 to the power minus X, it has now changed to 3 to the power X. That means the X has lost a negative there. And you know that grade 12, in order to change a negative to the positive, you must multiply it by another negative. Since the negative times the negative is a positive. So now in order to get a negative that you will multiply this one with to get a positive, we need to reflect this K function along the y-axis so that X gains a negative. That negative will come in and multiply with this one to form a positive. That is exactly what happened to a K function to form the G function. That's the first transformation this graph undergone, okay? And then now that is the what? Grade 12 reflection about the y-axis. Okay, and then now we are done with the comparison of 3 to the power minus X and 3 to the power X. Let's compare now. Minus 9 to be a minus 4. What happened? We have added a 5 there. Minus 9 plus 5 is a minus 4. That means grade 12, what have you done now? Remember, we have moved. Remember your graph now. I need your graph was initially having an asymptote at minus 9 here. And then we had a graph like that. That was cutting at minus 8 and minus 2 there. That is the K function. And then they say now the G function is 3 at X at minus 4. That means it will be cutting at minus 4 here. And then now that means the asymptote will now be at, if it is plus 5, it will, let's see, minus 4. Minus 9 plus 5 is a minus 4. Okay, the asymptote will be at minus 4. The graph will cut above that minus 4 there. Can you see now we compare minus 9 and minus 4, right? Check the movement now. You were at minus 9. And then you move minus 8, minus 7, minus 6, minus 5, minus 4. How many steps? 5 steps. In which direction? Upward. That is how you can also find that 5 units. It's minus 9 to minus 4. So minus 9, minus 8, negative 7, negative 6, negative 5, negative 4. How many units? 5. In which direction? Upward, because these have moved to minus 4. So that means now you have shifted or translated or shifted 5 units upwards. So those are the two transformations undergone by this G function from K. Okay. And then now we are moving to the second question now, different from the previous one. We are unfolding different types of asking an exponential function. We are still on the exponential function. So in this case, we are given t at x is equal to a to the power x plus t with the following information. Number one, they say y is equal to minus 1 is the equation of the asymptote grade 12. What does that mean? It means our C value here is a -1 because asymptote, remember, it's a y equal to the value that is represented by C there. Sometimes there's a Q there, but it means one and the same thing, okay? And then they say the A value is greater than 1. Greater than 1, that means it's not a fraction. If it is greater than 1, it is not a proper fraction. It is not between 0 and 1, like half, 1/3, 1/4, and so forth. It is greater, it can be 2, 2,5, and so on. So now that simply means this A is positive and it is also greater than. So they say sketch the graph of this function. Clearly show the intercept with the axis and the asymptote. The first thing that we know is that we are having the asymptote, which is y at y minus 1. So now we can have our graph here. The asymptote is at y minus 1. Right, and then if we are taking the original exponential function, y is equal to a to the power x then, right? If we want the y-intercept of this function, we are going to let x is equal to 0. So we end up with y equal to a to the power 0, of which is 1. So our y-intercept will be 1 there. So basically, grade 12, we will be having a graph that is cutting at y equal to 1, depending on the value of a, whether being positive. So this one is when a is greater than 0. Okay, and then now in this case, now they say a is greater than 1, and then the asymptote is at -1. That means if we compare, this was at cutting at 1 and the asymptote was at 0, the original. So if we add a -1 here, that means we are shifting this graph 1 unit down. The asymptote will also shift 1 unit down from 0 to -1 there. That is exactly what happened to this t function. So now that simply means now our graph of which is t at x, y equal to a to the power x minus 1 for C. If we want the y-intercept, we are going to let x equal to 0 minus 1. That will be 1 minus 1. Therefore, this graph will cut at y equal to 0 there. And then if a is positive, that means it's where your y value being positive greater than 1. So that is the graph you will be having grade 12. Sketching only using the properties. So this is cutting at 0 there. So the first mark will be for the shape, the second mark for the intercept, and the third mark for the asymptote. That is worth 3 marks. And then now sketch alongside the sketch. We are still on exponential function. We are now interpreting the sketch given to us. Can you see different ways of unfolding exponential functions? Sketched alongside is the graph of h at x equal to a to the power x plus d. And then now that means this is an h function. So t is the point. There we have your t. On the intersection, the point of intersection of P and H, and then A is -2, -1, and -2 is the point on H graph. The asymptote of H is indicated by dotted line. Can you see that? We have an asymptote there, which is indicated by a dotted line. The equation of that asymptote is y equal to -4. This simply means this is cutting at -4 there on the y-axis. This is our x-axis there. They say determine the equation of h now. Okay, so now we are going to rely on that point A, of which is -1 and -2, together with the asymptote y equal to -4. Do you still remember grade 12 that is representing the value? It's either D, they can use any letter, but the original equations are using a Q there. So now that -4 is for the asymptote, that means it's for that position. So we are going to take this A point for being our x and y to represent x and y coordinates. So in our graph, h at x, a to the power x plus d. So remember, h at x stands for y. That is a to the power x plus d. Then we are going to substitute the y value with the minus 2 and the x value with the minus 1. The value of d is our asymptote at minus 4. In order to find this equation, we need to determine the value of a. If we can find that value of a, therefore we will be having the h at x equation. And then now we transpose minus 4 to the left, it becomes a positive 4. And then the positive 4 minus 2, it will be positive 2. And then this a to the power minus 1, we take it back to its fraction. It will be 1 over a. Remember, if there's no denominator, it is 2 over 1. Then we cross multiply. That will be 2a equals to 1. Divide by 2 both sides. Our a is equals to half. Therefore, the h at x original equation, a to the power x plus d, we are now substituting what? The a value and the d value. We leave h at x because we need an equation. What is a? A is half to the power x. The value of d is a minus 4. Or it can be written as 2 to the power minus x minus 4. It's 1 and the same thing. And then grade 12, learn to check whether you are correct by comparing the equation that you have determined versus the graph that was given to you. And then now we can use this part here where it is telling us our x is negative and the y positive there. And then we look at the y positive is this side and the x negative is that. That means our arm must be away from our x-axis from that point. That is true, as you can see there. So now it corresponds with the equation that we have determined with the asymptote at minus 4. Therefore, we are 100% correct. So the first mark will go for substitution into the equation, the values of x and y. The second mark for substituting the asymptote value. And then the third mark for the correct value of a. And then now for correct substitution to determine the real equation of that exponential graph. Hyperbola function. With the hyperbola, we are given f at x is equal to 3 over x plus 1. And then they say write down the equations of the asymptotes. Can you see now? They say equations because they are more than one. It's not the same as the exponential. With the exponential, we are having only one, of which is the horizontal asymptote. But with the hyperbola, we are having two, the horizontal and the vertical asymptote. Okay, and then now let's start now. The first one is the x equal to, as you can see, there is nothing added there. That means it's plus 0. So now it will always be x equals to 0. And then the y1 will take the q1 there. So y will be equals to 1 in this case. And then this one is x equal to 0, is cutting a line x at 0. Therefore, it is the vertical asymptote. And then the y1, because it's cutting at y equal to 1, is the horizontal asymptote. So sometimes examiner can say, determine the horizontal asymptote. You must know exactly what are they looking for, grade 12. Do not mix them around. So it's 1 mark, 2 marks. So with all your hyperbola function, your vertical asymptote will be x equal to 0 for all your functions, only in technical mathematics, right? This graph of hyperbola will always have a denominator x there without any p added to that. P will always be a 0 there. Okay, so now your vertical asymptote for all your graphs hyperbola will be x equal to 0. That will be the first one. And the y1 will depend on the q value on your graph then. So it's a first mark, second mark, it's a 2 marks then. And then 4.2 now, you need to determine the x-intercept of f. The method is still the same. Grade 12 for x-intercept, you let y equal to 0 in all your functions. We are looking at the x-intercept, you let y equals to 0. And then remember this f at x represents the y, so we are going to substitute 0 to y, and then you are left with 3 over x plus 1. And then we transpose a 1 to the left, it's a minus 1. And then we have 3 over x. We cross multiply, that will be minus x equals to 3. And then divide by negative 1 both sides, x will be equal to a negative 3. That is the x-intercept for this particular hyperbola graph. And then you can also apply the LCD method if you are familiar with that one at this level where we are having 3 over x plus 1. You will be multiplying by x throughout because x is our LCD there. Lowest common denominator is x. And then if you multiply 0 by x, it will still be a 0. If you multiply 3 over x by x, it will be 3. And then if you multiply 1 by x, it will be x. And then you transpose 3 to the left-hand side, x will be equal to minus 3. So you can also do that grade 12. It's like you are just multiplying this x to that one. And then you'll be left with 3 plus x there. Multiplication of 0 will still remain a 0 there. So the first mark will be for substituting a 0, the second mark for your answer there. And then sketch the graph of f, clearly showing all the intercept with the axis and the asymptote. And then now when you sketch the graph, you need to identify the shape of the graph. Remember, the shape of this graph, it depends on the value of a. Our value of a in this case, it is positive greater than 0. If that is the case, that means our graph must lie in quadrant 1 and 3. If it is negative, it will be in quadrant 2 and 4 for a less than 0. Correct. Now, secondly, we need our asymptote. We have already calculated above. So now our first one will be x equal to 0, that's the vertical one, and the y equals to 1, that is the horizontal asymptote. Thirdly, you need the x-intercept. When y is 0, we have just calculated that above grade 12, and then we ended up with x equal to minus 3. We don't consider the y-intercept. Why? Let's see why not. Y-intercept when x is 0. Why are we not looking for the y-intercept? And then now when we let x equal to 0, this is what is happening. Y will be equal to 3 over 0 plus 1. Can you see division by 0 is not allowed? Your calculator will say error there to show that division by 0 is not allowed in mathematics. That is why we don't even consider calculating the y-intercept of this hyperbola function. You are okay if you have identified the shape, asymptote, and the x-intercept. It's more than enough information to sketch your graph. And then now the first asymptote is on x equal to 0. That means on top of this y-axis, because it's cutting the x line at 0 or x-axis. And then now the y asymptote is at y equals to positive 1. We are having our asymptote there. And then now this will assist us to identify. That means now these lines here, they serve as our asymptote, of which is that one and this one that is at y equals to 1. So our graph first arm will be there and the second one will be there because it's a positive graph. And then this will cut at x equal to minus 3. At x minus 3, there we are having our x-intercept. You have more than enough grade 12 to sketch the graph. Now this shape will assist you because it is telling you the first arm will be there, the second arm in there. And then now the first arm will be a free arm in this quadrant here. Do not touch that because it's an asymptote. Do not touch there, it's an asymptote. It will cut at 3 there, at -3 for x-axis. Do not touch the asymptote, and it will go closer to that one also without touching the asymptote. So that is how you sketch your hyperbola graph. Right, we are still on hyperbola. Unfolding another way of asking the question, sketch the graph of function p, which is defined by p at x equal to -4 over x plus q, and it satisfies the following properties. It says x must not be equal to 0. Why? Because this is an asymptote. So it simply tells us we are having an asymptote at x equal to 0. Right. And then we are having p at x is equal to -2. Remember, I indicated that this p at x represents y. That means we are having another asymptote now at y equal to -2. And then at p equal to -2, if x is -2, y is equal to 0. So we have a coordinate. This graph is passing at x -2, and then which gives a y equal to 0 there. And then these are the properties that we are relying on to sketch that particular graph. And then at least the a values given as b -4 there. Okay, so this one is indicating the shape will be in quadrant 2 and 3 because this graph is a negative graph. Can we now sketch the graph, grade 12s? Yes, we can do so with those properties. And then now we have the first asymptote. It will always be on top of the y-axis, one of your asymptote. And then the y1 is at -2. And then this graph is cutting at -2 and 0. If x is -2, y is 0. 1, 2, -2, x 2 and y 0. X -2 and y 0. So basically this is what is indicated there as being the given information on the properties given. And then now according to this, according to -4, a value negative, it is telling us that this graph will be in quadrant 2 and 4. That means it is in here and on that particular side. For this arm, we are going to draw a free arm. It must not touch, it must not touch there. And then now, on this particular side, we have an arm. It must not touch the y-axis. It must pass through your x-intercept -2. And then it must not touch the asymptote at -2. So that is the expected graph. One mark will be for the asymptote, the second mark for the intercept, the third mark will be for the shape of the graph. That is how we allocate the 3 marks for that particular graph. I hope we are still together. And then now we are interpreting or analyzing the hyperbola graph now. Activity 6. The diagram represents the graph of the function defined by f at x is equal to a over x plus q, and then r -2 and 4 is the point on f as indicated there. And then now g is a line of symmetry of f which cuts the y-axis at 2. This is our line of symmetry at y equal to 2. And then remember, we do have another asymptote line on top of the y-axis, of which is the line x equal to 0 there. And then now w is the x-intercept. We have a point w there is the x-intercept of your f function. And then now point V is on G. G is a straight line. And then point V is on that particular straight line, such that VW is perpendicular. The perpendicular cap is indicated there, grade 12, to the x-axis. Then we need to determine the equation of f. Now let's take the equation original given to us is f at x equal to a over x plus a q. Remember, this one is representing the asymptote, which is the horizontal asymptote, of which is that value there, y equal to 2. And then we have a point on that graph of which is r. And then coordinates of r are minus 2 and 4. We are going to treat this as our x and y in coordinate form. And then now for the asymptote, we'll substitute a positive 2. So f at x represents y, of which is 4. And then we have a. The denominator x will take a minus 2. A q will take a positive 2 of the asymptote. And then we are solving for a. Can we see grade 12? As long as we can have the value of a, therefore we will be having the equation for this particular graph. And then now let's do so. Simplify. We transpose a 2 to the left-hand side. It will change to negative 2. So a 4 minus 2 will be a positive 2, a over minus 2. And then cross multiply. 2 times minus 2 minus 4. And then a multiplied by 1 is then a. Therefore, our a is equal to minus 4. Then we end up with an equation f at x is equal to a is minus 4 over x with the asymptote plus 2. That is 100% correct, grade 12. So the first mark will be for substitution of q. The second mark for the value of a for q and the x and y point, first mark. Second mark for the a, and then the third mark for putting everything to give the final equation of f at x now with values. That is how we allocate marks for that particular graphs. And then 6.2, the diagram, we are still on the same diagram, same f at x equation, but we now know the equation of the graph is f at x equals to minus 4 over x plus a 2 as we have calculated above. And then now they say write down the range of f. The range, we are talking the y values of this particular graph. And then if we check now, we are having a graph above positive 2 and the graph below positive 2. The only challenge that is this line is an asymptote now. So yes, if it wasn't of this asymptote, we will say y is an element of all real numbers for this range. But in this case, 2 is excluded because it's an asymptote. We will say, but y must not be equals to 2. So basically, grade 12, what we are doing is that we are excluding this asymptote line. Y must not be equal to 2. So for all hyperbola function, the range will say y element of real numbers. Yours is only to do what? Exclude the y asymptote. Then you will be the master of the range of hyperbola function. The same applies with the x. Ne? The x will be x element of real numbers. X must not be equal to 0. For all your hyperbola function, the domain is the same. For all your hyperbola functions, the domain is the same, of which is x element. If in this case we were expected to write the domain also for this, it will be x element of real numbers. X must not be equal to 0, but this one is applicable to all hyperbola functions, only in technical maths. Okay. Those are 3 marks grade terms. And then now still on the same graph of f at x equals to minus 4 over x plus 2. That is our equation. We are determining the coordinates of w then. But if you look at w is the x-intercept of f. Oh, if it is the x-intercept, therefore we let y equal to 0. x-intercept, we let y equals to a 0 in our equation. Remember, the f at x is representing y. So y is 0 equals to minus 4 over x plus a 2. And then we transpose a 2 to the left. It is becoming minus 2. And then we are left with minus 4 over x. We cross multiply. That will be minus 2 times x, which is minus 2x. And then 1 multiplied by negative 4 is a negative 4. Divide both sides by negative 2x is equals to a positive 2. Can you see that? It's on the positive side. Therefore, the coordinates of w will be what? X equal to 2 and the y equal to 0 because you let y equal to 0 there. And then we are given the answer in coordinate form because they've indicated coordinates of w there. That is why we are putting this in coordinate form. It's a must grade 12 because the question states that determine the coordinate. And then now another way of doing this, you can use that LCD method from this step, x by 0, 0, and then minus 4 over x multiplied by x minus 4, and then 2 times x is 2x. 2x transpose minus 4 to the side, positive 4 divided by 2, x is equal to 2. Exactly the same x value as that one. So allocation of marks will be 1 for substituting the 0, and then second mark for the correct x value, the third mark for writing the answer in coordinate form, 2 and 0 there. And then we move on to the next graph, number 3. We are looking at the parabola function, and then we are given the function of f defined by f at x is equal to minus x squared minus 6x plus 7. So our first question here, we need to write down the y-intercept of the f. It says write down. The minute it says write down, no calculation, the answer is already on your question. So now if you let x, remember when you look at the y-intercept, you let x equal to 0. If you let x equal to 0 there and x equal to 0, that means this portion here will be 0. So can you see now your y is equals to 7 is your y-intercept. Done. 1 mark. And then now secondly, 7.2, you need to determine the x-intercept of f now. For the x-intercept, we let y equal to 0. Yes, y we are equal to 0. And then we have minus x squared minus 6x plus 7 as being our quadratic equation. But remember, quadratic factorization, you need to get rid of the negative on the x squared before you factorize. So we are going to multiply throughout by negative to remove the negative there. And negative times negative, it is positive x squared minus 6x times negative, positive 6x. Positive 7 multiplied by negative is the negative 7. Happy now, grade 12. We are looking at factors of 7. When you subtract them, they give you a positive 6. What are factors of 7? Possible factors of 7 are only 1 times 7. We don't have any other factors of 7 except 1 and 7. Okay, so now we are relying on that 1 and 7. It's an x and x, a 1 and the 7. And the middle term must take the sign of the bigger number. And then the other bracket must be negative in order to end up with the product, a negative. So if we need a positive 6, bigger number must be positive. And then subtract a 1 from 7 to get a 6, middle term. That is why you have noted our signs as being minus 1 and the plus 7 for our factors. Therefore, for the first bracket, x will be equal to 1. Or for the second bracket, our x will be equal to a negative 7. And then grade 12, you are more than welcome to use your quadratic formula for those who are comfortable with the quadratic formula method, with the substitution continuously so, okay? use your quadratic, you are more than welcome to do that. And then the 3 marks, we will be allocating 1 mark for equating to 0 for the factors, and then for both your x values then. And then moving on to the next activity, we are still on the parabola graph. They say determine the coordinates of the turning points of f. We are now looking at the turning points. We have different ways of doing that, grade 12s. The first one, you can use the formula at the back of your formula sheet. It says that x is equal to minus b over 2a for the turning point. And then remember, this is still your a value. And then minus 6 will be the b value. And then 7 is your c value there. So we need the b value for this one. We have a negative from the equation there. Our b comes with another negative. It is bringing in another negative. It's minus 6 only, not 6x. Sorry for that. And then we have a 2, and the a value is minus 1. Be careful of the signs, grade 12. Negative by negative here will give us the positive. 2 times negative 1 is a minus 2. So this will give us basically a minus 3 as the x turning point value. So we need coordinate. It must be x and y. So to get a y, we are going to substitute this minus 3 into our original equation there. Therefore, we'll be having f at minus 3 is equal to minus 3 squared minus 6 minus 3 plus 7. Therefore, this is representing the y value of which it will be a 16 there. So these coordinates of a turning point for this particular quadratic or parabola graph, it will be x minus 3 coordinating with y 16. So if you don't want to use that, you use that method of x equal to minus b over 2a, you can use your calculus, grade 12. You now know how to use calculus to find your stationary point. You take f at x, the same method that you use for stationary in calculus can also be used to find the turning point of a parabola, of which you derive the equation. That will be minus 2x minus 6. You let it equal to 0. And then you continue simplifying. We are going to transpose minus 2 to the left. It will be positive 2x equal to minus 6. Divide by 2 both sides, then x will be equal to a minus 3. Can you see? We end up with the same x values there, of which they will yield the same y value there, which is 16. All right. Or basically, you can use the formula at the back of your formula sheet, of which you determine your y turning point. Any method, grade 12, that you are comfortable with is more than welcome. And then 7.4, hence sketch the graph of f. We are sketching the graph of f. Now, what do you need in order to sketch a parabola, grade 12? Number 1, you need to identify the shape of the graph by looking at your equation now. The value of a, of which is this value here, it is negative, therefore is less than 0. So we are expecting the shape that is concave down. And then number 2, you must look at your y-intercept. You have already calculated that above. And then we end up with y equal to 7 as our y-intercept. And then you must calculate the x-intercept. We have ended up with the x-intercept being y equal to x-intercept x equal to minus 7, and the x equals to 1. And then you calculate the turning point. You can't draw a parabola graph without having all of this, grade 12. And then for the turning point, you have just calculated above. We ended with minus 3 coordinating with 16 there. So that is all that we need in order to sketch the parabola graph. And then we can now start sketching. We need x equal to 1 as the x-intercept, and then the x equal to minus 7 as the x-intercept there. And then we need the y equal to 7 as our y-intercept. And then we need a turning point coordinating minus 3 with a 16. So this is sharing a point because they are coordinating. -3 and 16 there will be our turning point. And then our graph is concave down according to the shape that we have identified there. So this will cut on the -7, x-intercept, cut the y-intercept at 7, cut the x-intercept again at 1. So basically, this is the expected graph of that particular equation. Okay, and then now moving on to the next question, we are still on the f at x parabola function on the same set of axes. Now remember, we have already sketched this graph as indicated here on the previous question, of which is coordinating our turning point -3 and 16 there. On the same set of axes, sketch the graph of h, and then h is defined by h at x equal to 2x plus 14. Clearly show the intercept with the axis. And then now grade 12, it's very important to know your original equation so that it can be easier for you when you see an equation, you automatically know what type of a graph is that one. So if you look at this one, this is x to the power 1, therefore it's a straight line graph or a linear function. Now to sketch a graph linear, you look at the gradient here, that is the coefficient. If your gradient is, to identify the shape, we look at the gradient. In this case, the gradient is greater than 0, meaning is positive. Therefore, our graph will be an increasing graph because m is positive. Okay, increasing graph because m is positive. Secondly, you must look at the y-intercept, same method. When x is 0, we let x equal to 0. In the equation y equal to 2, we let x equal to 0. Can you see your y will be 14? This part here will be a 0. And then that is y-intercept. For x-intercept, we let y equal to 0. And then that means this h at x represents a y. So it will be 0 equal to 2x plus 14. We transpose 14, it will be minus 14 to the left. 2x divided by 2 both sides, therefore x will be equal to -7. That is the x-intercept, the y-intercept, and the shape of the graph. Let's sketch the graph. For straight line, you only need your x-intercept, y-intercept, and identifying the shape. So x -7 there, it's our first point, and then y will be 14. Remember, this parabola is cutting at 7 here. So we are looking at 14. So now this straight line will cut there. So we are having the straight line passing through 14 on y, cutting -7. So that is the h function. So this is 2 marks. It is 1 for the shape and the 1 for the intercept there. I hope we are still together, grade 12. And then 7.6 now, calculate the values of x for which you are calculating them. You don't use the graph to predict that. Yes, you can use the graph to find the solution, but in this case, the examiner is saying calculate the values of x for which f at x is greater and equal to the h at x. Do you still remember the h at x equation? H at x is equal to 2x plus 14. That is our h at x function. So we are going to take this and solve for x there because they say we must calculate. But basically, if we are not calculating here, we will be looking at the graph and then predicting all the solutions from our graph here. Okay, where f is above, that means it's from this point to that one. This statement, it states that f is above and then h at x is below, because f at x is greater than h at x. So is this part of the graph for which values of x? Can you see -7 is part of the solution? So ours is to determine the other value there that is suitable for this graph. Let's do so, grade 12, by means of a calculation. We are having f at x minus x squared minus 6x plus 7, I am substituting in here, is greater and equal to the h at x, 2x plus 14. We are solving for x. Can you see? This is the quadratic inequality. It's your question 1 of your algebra inequalities. And then we transpose everything to the left so that we can have a 0 on the right hand side. You know the tricks around inequalities, grade 12. So you have minus x squared here, and then 2x to this side will be minus 2x, minus 6x minus 2 is minus 8x, and then 14 positive to this side negative, minus 14 plus 7 minus 7 greater and equal to 0. And then we cannot factorize with a negative on x squared. We are going to multiply through by a negative. The minute you multiply by a negative is going to affect your inequality sign. I hope you still remember that, grade 12. We are multiplying by a negative throughout. This will be positive x squared plus 8x plus 7. Inequality sign will now be less than equal to 0. No more bigger than, it is now less than or smaller than 0. Then we factorize. We are looking for factors of 7. When you add them, they give you 8. So now everything is positive. That means both our bracket will be positive. Factors of 7 are only 1 and 7. So we split x squared, x to each bracket. And then now we'll be having critical values. We are criticized in these values because we are now bringing an equal sign, although we are solving an inequality, not an equation. Equal sign is for equations. Greater, less than, greater and equal to, less and equal to, those are inequalities. And then now we are criticizing the values because we are saying x is equal to minus 7 or x equal to minus 1. This is not yet the solution, grade 12. Remember, you are solving inequalities. So we are going to have our inequality here. Smaller number, minus 7 is smaller than minus 1. Remember, negative values, do not be confused. Minus 7 is smaller than minus 1. Our inequality sign is having a closed dot there. Then we are considering the new one, not the original one. So we are looking where the graph is less than. That means we are shading in. Then x will be in between. It is included, minus 7 and minus 1, because this is also included. Can you see that? Minus 7 is part of your solution. And then this intersection here is having x value at minus 1. So these are the values of x for that interval, grade 12. And then we move on to the second graph. And then now the first one, we are given a function p defined by p at x is equal to minus. Can you see it's a negative graph? So now we are expecting a graph that will be cutting on the negative y value. Remember, a circle, we don't have the arrows that is showing continuation of the graph. No. It stops immediately on the radius. Do not put in arrows, grade 12. Okay? And then now, this is the shape we are projecting now. Now, to sketch a circle, we are depending on the value of r. Remember, this 13 here, it is substituted on the space where we are having the r squared. Original, do you still remember? It's y equal to plus or minus, this one is the minus 1, square root of r squared minus x squared. So now we are depending on this value here in order to sketch our graph. So now our r squared is equals to 13. But we need a radius, the actual radius, not r squared, so that we can know how much is that point, this one, and also the y-intercept of this. That means this will be plus minus the square root of 13. So grade 12, basically, we are having a semicircle that is negative. That means it is cutting on the negative y value because y is negative, correct? And then now our radius on this side is the negative x square root of 13. And then the x, this side will be positive square root of 13. And then on the y-axis, because it's on the negative y, it will be negative square root of 13. Why? Because the radius of the circle from the center, 0. This is the center of the circle, is equal, which is square root 13 units, all the directions there. So that is the graph we are expecting. The first mark will be for the x-intercept, second mark for the y-intercept, the third mark for the shape of the graph. Hence, this is worth 3 marks. And then activity 9, sketched are the graphs of f and g. We are now interpreting this graph. We have the semicircle, still negatives, cutting on the y negative, and the g at x, 2x minus 1 respectively. This g at x is a straight line. How do we know is x to the power 1 there? And they are passing through point A there, and also point C, of which is the x-intercept for both your semicircle and your straight line. They say determine the coordinates of C. C is the x-intercept for both graphs, but we can't take the f function, try to find the value of C, because we don't have a radius there. The radius is unknown. So we will rely on the straight line, whereby we are calculating the x-intercept of a straight line. It will assist us to find that point C coordinates, where y is equal to 0. So on the straight line g function, g at x is 0, and then we have 2x minus 10 there. And then we transpose minus 10 to the left, becomes positive 10. We are left with 2x. Divide by 2 both sides, therefore x is equals to 5. Therefore, the coordinates of C, x is 5 with the y 0 there. So that is 2 marks for that. Okay, for finding the correct x value, and then in coordinate form 5 and 0, because they say in coordinate there. So what does this mean, grade 12 now? It means here, also for the circle, it is 5. Radius is 5. It will also be 5 units, but negative 5 because it's on the negative. Also, B will be negative 5 because the radius is the same throughout your circle. Okay. And then determine the length of BD. Remember, we have already identified that this will take a negative 5, right? And then if you look at D, the D is the y-intercept of a straight line. So we need the distance between B and D there. Okay, so we are going to calculate first how much is D, because automatically we know B is 5 units there from the origin there. So now we are going to calculate D, which is the y-intercept of a straight line G. We let x equal to 0. If x is 0 there, that means the y for G at x will be minus 10. So this point here is minus 10. So what is the distance in between there? The length of BD. BD is how many? 5 units. Because from minus 5, minus 6, minus 7, minus 8, negative 9, negative 10 is 5 units downward there. So now we will look at that calculation and the final answer there. Okay, that is your 2 marks. And then we are still on the circle. Determine the equation of F. F is that semicircle negative. If you know your radius, grade 12, automatically you know your answer. We have already indicated that this will take that 5, of which is the x-intercept of a straight line. That will be your radius. So now if R is equal to plus minus 5, then the R squared will be plus minus 5 squared, of which is how much? 25. Therefore, the equation of f at x will be equal to minus the square root of 25 minus x squared. That is 1 mark, because some learners, they can just predict that this is 5 from there, then square the 5 to 25 and give the solution. So the mark will be allocated for the final equation. 9.4, determine the values of x for which g minus f is greater than 0. And then now this simply means, grade 12, the g at x If we transpose this to the side, it will be greater than f at x. If it is greater, that means g is above and then f is below. So we are going to check for which values of x is g above and f below. They say determine that. Okay. Now G is the straight line graph, and then it must be above the f graph. The first thing that we need to take care of, grade 12, is that the f function stops there. That means, yes, we have an arm here for the g function, but there is no f function for that interval. So yes, we cut off that part. We are going to look at where is g above the f function. So g is above, g is the straight line from this point A to point C. Can you see? Is the one that is above the f function. So for which values of x? Remember we said C here is 5, correct? So between values of x, 3 and 5. Between values of x, 3 and 5. This is not included. We are not going to include our x values there. So the answer will be 2 marks for that allocation of marks. Okay, and then now we have the combination of a hyperbola with the parabola function. And then that means we are interpreting now the graphs, but now these graphs are now combined. They can combine any two graphs, grade 12. You must be able to analyze or interpret them. In this case, we are given the f at x function equal to minus negative into x minus 4 and into x plus 2. That is your parabola graph. And then the equation for the hyperbola is the unknown one, of which is g at x equal to k over x plus q. And they say A, B, and C are the intercepts of f, of the parabola. A, B, and C, those are the intercept. These ones are the x-intercept. That one is the y-intercept. And then A is also an x-intercept for G. Can you see that? It is on both graphs. And then D is the turning point of f, and then it's also an asymptote to the G function. And then now write down the x-coordinate of A and B. Write down. That means your answer is on the given information. So you must be specific, grade 12, that which x value is for A and then which x value is for B. Okay? You can't just write x equal to x equal to, because they say the x coordinate of A and B. The x for A, let's see now. We are having the first x, which is x equal to 4. They have already factorized for us. And then x equal to minus 2. Now you go to your graph and check the position of A. A is on the negative x values. That means this one will be XA. So XA will be negative 2. And then obvious the XB will take a 4 because it's on the positive x values. So that is how you determine that. Simple, straight, and forward. Determine the coordinate of D. D is the turning point there. Look at the equation now. Can you see that you can't determine what is x, what is A, what is B? So you need to get rid of the bracket and take this equation to its original equation. So this is f at x. Now we are now going to remove the bracket. We start by multiplying x times x is x squared. X times 2, that is 2x. Minus 4 times x minus 4x. Minus 4x plus 2 is minus 2x. And then the negative 4 times 2, that is negative 8. Distributive law of multiplication, grade 12s. I know you are very familiar with that one. We are using it more often. And then we are going to multiply a negative in. It will be minus x squared plus the 2x plus an 8. Can you see that now? So you can apply either the calculus or the formula x equal to minus b over 2a. If you are applying calculus, you derive this. It will be minus 2x plus 2. You let it equal to 0. And then now minus 2x will be equal to minus 2. Divide by minus 2, both sides, x will be equal to 1. That is your x turning point. It's not an intercept, right? And then now we are going to substitute this one into your equation. That will be f at x, or the y turning point, minus 1 minus 4. We are substituting into our original there. And then we have 1 plus 2 there. And then if you put this into your calculator, you end up with a 9 there. So the turning point D coordinates will be 1 and 9. And then this is 3 marks. It will be 1 for the method here, the second one for the x value, and then for the 9 in coordinate form though. And then write down the range of f. Can you see now? F, it tends at 9. The y value is 9 there. So there's no way that you can have this graph of parabola above here. It only appears from 9 going to the negative infinity. Now, if we write a range, we'll say range is y less than, because it's the graph less from positive 9. It's less than equal to, because 9 is part of the turning point there. Then this is worth 1 mark. And then write down the equation of the asymptote of G. Remember, we said this is 9 here. Then the asymptote of G will be what? Grade 12, y equal to 9. It's an asymptote because that Q value is 9 according to this turning point value there. Then this is worth 2 marks. Equation of the asymptote. Oh, for hyperbola, we have 2. Do not forget that. X equal to 0, your free mark. So 1 mark will be for y equal to 9, and the second mark for x equal to 0. Remember, there is that asymptote which is on top of your y-axis there. It is invisible because it's on top of your y-axis. Determine the numerical value of k. K is the value on top there for the hyperbola function. So we are determining that value. So if we can have x and y to substitute here, we already have the value of q, of which is 9 here. Okay, go back to the equation. Now try to find a point that lies on that hyperbola. Happy now we have value of point A that lies on the graph. Do you still remember coordinates of A? We have calculated the x value above. That is minus 2. So this will coordinate with 0 because it's the x-intercept. So we are going to take this as our x and y because it also lies on the hyperbola graph. So we are having y is equal to k over x plus q. Then we are substituting y with the 0. And then we are looking for k, the x with the minus 2, the q with the plus 9. Transpose a q, minus 9 is equal to minus k over 2. And then minus 2 cross multiply into 9. That will be minus 9 times minus 2 equals to k, of which it gives us 18. So the real equation, but they say determine numerical value of k. You can stop there, grade 12. But if they say an equation, then you'll give us an equation. G at x, therefore, is equal to 18 over x plus 9. And then allocation of marks is to let that equal to 0 and then substitute 0 and minus 2. And then the second mark will be for substituting the asymptote 9. And then the last mark will be for value of k, of which is 18 there. Right, and then determine the value of x for which g is less and equal to 0. The g function, that means we are talking to the hyperbola graph. G function. Being less means where it is negative now. Less and equal to 0, negative and equal to 0. So now our graphs are negative below the x-axis. Below the x-axis, the graph is negative. Above the x-axis, the graphs are positive. That simply means here we are having positive, 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 positive. All this part is positive here. The minute they go below, they are now negative. Okay, but we are looking at the hyperbola graph, the G graph, where it is negative. That means it's from this point going down, but it will never touch this one because it's an asymptote. It will continue going down in this direction. Can you see now it's between, is this portion here? That means it's between this x and the 0 there. So that means it's x between what? A, coordinate of A is -2 and 0. And then this one will be between -2 and the 0 there. Now, this is having an equal sign. Can we include -2? Yes. Can we include 0? No, because now this is an asymptote. It cannot be equal to a 0. Be careful, grade 12 of that one. So 2 marks allocated, but your inequalities must be 100% correct in order to be able to give the correct answer. And then now the value of k, we are giving a sketch there, f at x is equal to that, and the g at x equals to that straight line. PM is perpendicular. PM is from here to there. The PM from to the x-axis there. And then AB from A to B is perpendicular to the x-axis. And then C is a point on the straight line there. And then the coordinates of A are 4 and K as indicated there. And it's a point on a parabola graph. They say find the value of K. Since this is on the parabola, we are going to substitute this as x and y on the parabola graph. Y equal to x squared minus 2x plus 4. What is y? K. X is 4 squared minus 2 into 4 plus 4. K is equals to, straight into your calculator, grade 12, our K is equals to 12. 2 marks, 1 for substitution of 4, and then the K value is another mark. The length of AC, K is now for this point A here, it's 4 and 12. And then now we want the length of AC. Can you see it's between the parabola and the straight line? We already know that the length here is 12 units from the 0 point up to there is 12 units. If we can find the length from here, 0 to C, we will be able to subtract the 2 to have only this part we want. We only need this one in between there. So now we can set the x value for C here. It is still that 4. All what we don't know is the value of y. This simply means now we can take the straight line graph and substitute that x value 4 in order to get the y value of which is 5. This simply means now the correct coordinate is 4 and 5 for that one. So what is the distance between 12 and 5? Grade 12. 5, 6, 7, 8, 9, 10, 11, 12. How many units? 7 units. Therefore, AC is equal to 7 units. Or you can say 12 minus 5, which is equal to 7 units there. And then now, next question. Coordinates of P. P is that point. We already know that we have A here, which is 4 and 12. That means for P here, we already know that the Y value, we don't know the X value, but we know they are sharing the same Y value since the line is perpendicular there. So then this P lies on which graph? On a parabola graph. Oh yes, we are going to take the parabola graph. X squared minus 2x plus 4. What is the Y value for P? Y value is 12. Then we can now check the X value for that particular point. Transpose 12 to the right, it's becoming a negative 12. Then minus 12 plus 4, it is a minus 8. Factors of 8, when you subtract, you get a negative 2. That will be 4 and 2. Middle term, take the sign of the bigger number. The sign must be different because you are looking for minus 8. For negative 8 there. So x is equal to, therefore, for the first bracket, x is equal to 4. For the second bracket, x is equal to minus 2. Can you see grade 12? The x equal to 4 is for A. It can't be for P again. P is on the negative x values. Therefore, x for P will be minus 2. So in coordinate form, because they say coordinate, P will be minus 2 and 12. 1 mark for that, for the factors. and then for the conclusion in coordinate form there. Okay, and then now let's look at the little bit of finance and growth there. The finance, after the completion of this, you must understand the implication of fluctuation of foreign exchange rate. Remember, different countries, others use rands, dollars, pounds, and so forth. That is the understanding that it must be clear to you. And then to use simple and compound growth formula, that is the simple depreciating and appreciating. And this is the compound growth to solve problems, including interest, high purchase, inflation, population growth, and other real problems, real life problems. To analyze the effects of period on compounding growth and decay. This includes the effective rate and the nominal rate, but is not limited to the finance only. And then you must be able to critically analyze different loans options so that you can wisely select the correct or the most one that is favoring your interest grade 12s. And then now simple notes on this. Remember, you have simple interest formula where A is equal to plus if it is an interest one. If it is a decay, it will be a minus formula. For compound interest, for interest, it will be plus. For a decay, it will be a minus. Nominal effective rate, we are using this formula. IE is for effective, I nominal, and then this one is your compounding, whether it's compounded monthly or quarterly then. And then each letter there meaning same thing throughout. A means the final amount, the P means the principal or the initial amount invested or the initial price of whatever item you want to buy. I is the interest rate, depending on different interest rate. N is the number of periods or number of terms, and then IE is the effective rate, and then I is the nominal interest rate, and then M is the different periods of compound growth or decay, and the capital I, look at the difference for that, is the interest charged on a loan or interest you earn after investing a money for 5 years. The interest that is added, total interest, is the capital I. But the small I is the interest rate, maybe compounded at a rate of 10% is added monthly. That is an interest small rate at which the capital interest is calculated on. Okay, that is the difference between the two. And then now we are compounding annually. It happens once in a year. I will not be affected and N will remain the same. If we are compounding annually, half yearly, semi-annually is half of the year. After 6 months, we add interest. Another 6 months in a year, then it will happen twice. That is why we say number of terms is 2. Your I will be divided by 2. The period will be 2 times the period. Quarterly is after 3 months. So the first 3, 6, 9, 12, it will happen 4 times in a year. Then I will be affected by dividing by 4. And the number of years also will be affected by 4. Monthly compounding is every month, January to December. We have 12 months. That means it's 12 terms. And then I will be I over 12 and 12. Weekly, we have 52 weeks in a year. And then I will be affected accordingly. Daily, we have 365 years if it's not a leap year. If it's a leap year, it will be 366 years. And then that will affect our I and N respectively. So now let's take the first activity there. A school buys tablets with a total cost of 140,000. And then if the average inflation rate is 6.1 per annum over the following 4 years, determine the cost to replace these tablets after 4 years. So that means we are having the initial cost price of this, which is 140,000. And then this was calculated at an interest rate of 6.1%. And then for a period of 4 years. Okay, and then we want to replace these tablets after 4 years. That means now the value will be appreciating. So we use the formula A. If it's an inflation, it's a compound interest grade 12. Then it will be 1 plus I to the power N, not the simple one, right? And then principal amount will be 140,000, the initial price, 1 plus the rate 6.1%. And then the number of years will be for 4 years. And then the new price of buying the same number of tablets after the period of 4 years, now you will need to have 177,414.69 cents in order to buy the same number of tablets after 4 years. Same type, same number of tablets. So 3 marks is for the correct formula for substitution and your final value then. Activity number 2, still on finance. The normal engine coolant, that means this financial problems can relate to real life situations at some conditions. Normal engine coolant temperature of a certain car is 90 degrees now. Due to a technical problem, the engine of the car overheated. You know it happens that you find your car overheating and so forth. And then now this increases the temperature to 159 degrees due to the overheating. Determine the time in minutes that it will take the engine to cool down to the normal ECT. So if it is cooling down, that means that it is now depreciating, okay? At a decreasing rate, it is decreasing. Can you see it's going down? Of which is 8%. So now we have started with P initial, the temperature was 90 degrees, and then it ended up, the final one being 159 after overheating. And this was happening at a rate of 8%, right? And then now we want to determine time. So we need the value of N here. So it will be A, P, and then into 1 minus I, because it is decreasing to the power N. What is the final temperature? 159 degrees. Can you see now if it is 159 degrees is the temperature, because the temperature is increasing now. And then now P was 90 degrees Celsius. And then now 1 minus the rate is, okay, colleagues, I think let's read again. The normal engine coolant of a certain car is 90 degrees. Due to a technical, the engine overheated, which resulted in an ECT reading 159. Determine the time it took the engine to cool down to the normal ECT. Okay, it is cooling down to the normal. So it moves from A, the overheated, of which it is P, the initial overheated is 159 degrees Celsius. Sorry for that, grade 12. We are starting from the overheating. 159 will be our initial, because we are calculating when it drops down, right? And then when it drops down, we want it to end at the normal heat of 90 degrees. We must be very careful when we are reading your statement, okay? And then with the same rate of 8%, right? And then now our substitution, our A will be that 90 degrees, because now we are reducing the heat. We want it to cool down from the 159 degrees Celsius. And then now 1 minus the rate of 8%. And then we are looking at N there. Divide both sides by 159. We'll end up with 30 over 53. We are still in degrees Celsius. On the right hand side, this one minus 8% is giving us 0.92. And then to the power N. We now bring in our logs. That is 30 over 53 log. And then base 0.92. You know, grade 12, in order to bring an exponent down, you need to bring in your logs now. So N will be equals to 6.83. Those are the minutes we need in order to cool down that particular engine. And then determine the loan amount that an artisan had to take out of this deal. And then the deal is that an artisan wants to buy a car after seeing an advertisement alongside. The advertisement is saying the new car price is 250,000. That is the principal amount. And then this guy pays a deposit of 10% to reduce the price of the car, and then take a loan for the balance. and then pay the loan with equal monthly installment over 5 years, and then with the rate of 6.3, and then this is compounded monthly. There are so many things that are happening in the grade 12. There are so many things. Okay, and then now first one, 3.1, they say determine the loan amount that an artisan had to take out of this deal. Why? Because he is paying a deposit of 10%. If you pay a deposit of 10%, how much will be left is 90% of that amount. So this is the money you will be taking as a loan. 90% of 250,000 will be taken on a loan. How much is that one? This is your loan. How much is 90% of that amount? That is 225,000. Or grade 12, you can start by calculating the 10% of 250,000. That will give you 25,000. And then you subtract this 25,000 from the 250,000. You will still get the same loan, which is 225,000. And then 3.2, they say correct one decimal, calculate the annual effective rate. You take the formula, is on the formula sheet, i.e. at the back of your question paper. And then this will be y plus I nominal over compounding to the compounding minus 1. Let's substitute now. It's y. What is nominal rate here? 6.3%. Compounded monthly 12. Do not bring in the years. 12 minus 1. And then now this will give you decimal values of which is 0.06485 and so on. Leave it like that, grade 12. Multiply this by 100 to take it to the effective interest rate. And then this will be how much now? 6.5%, because they say to one decimal place. All right. And then now another question. An engineering company purchased the printer. That is the price of the printer. The value of the printer depreciate goes down at a rate of 20%. That is the I. And then using reducing balance. Reducing balance means it's the compound interest method. Okay. And then write down the value of the printer. If it depreciated, it goes down to 1/3 of the original. 1/3. What is 1/3 of the original now? So it will be 1/3 of the original 81,000. What is the 1/3 of 81,000? Grade 12. That is 27,000 in rands. Okay, and then 4.2. Determine how long it will take for the printer to depreciate to its 1/3. Now, how long? That means you are looking for the value of n. And then this is the reducing balance. It's the compound interest A equal to P into 1. Because it's depreciating, it will be minus I to the power n. And then what is the amount? It is depreciated to this value, 27. It moved from 81,000 to 27,000. Okay. 27,000 equal to initial, we were having 81,000 value of the printer. 1 minus the rate is equal to 20%. Okay. And then this is to the power n. We are looking for that n. Okay, so what we do now, we are going to divide both sides to get rid of this 81,000. And then if you divide by 81,000 both sides, you end up with 1/3 is equal to this bracket here. 1 minus 20,000 give us 0.8. And then this is to the power n. You want to bring an exponent n down, you bring in a log. Log of 1/3 base 0.8 and then n. What is the base will still be a base on your log. Okay, so we end up with n equal to 4.92 years in order for the printer to depreciate to its original value there. Okay, we are almost there. Grade 12, activity 5. They invested amount of money into an account that earned an interest rate of 6.78 per annum. And then now this is compounded monthly. This is the interest rate. We don't know the amount of money that was invested. And then this is compounded monthly. Then at the end of 2 years, the interest rate changes to 5.2. And then this is compounded quarterly now. And the value of the investment at the end of the investment, it will be 50,962.58 at the end of how many? 3.5, 3.5 year total period of investment. So now determine the initial amount of money that they invested. So since you are having so many changes of compounding and so forth, this is a timeline type of question. So we started initially. We don't know how much was invested initially. But this one is invested for the first 2 years. And then for the first 2 years, the interest rate was 6.78%. Compounded monthly divided by 12. 2 years multiply by 12 because it's compounded monthly for the period of 2 years. Okay, and then now for the remaining period, remember out of 3.5, out of period of 3.5, if we take 2 years, we are left with 1.5 in order to have 3.5. So for this part here, we are having 1.5, 1.5 year remaining. Now, at the end of 2 years, the interest rate changes. Interest rate changes to what? 5.2. 5.20 is the same as 5.2. Compounded quarterly, therefore we divide by 4. The minute we divide I by 4, we must also multiply n by 4. Can you see that? So this is what is happening. But this investment now, at the end, we are going to receive an amount of 50,962.58. And this is worth 6 marks grade 12. Let's see now. Okay, we are having an A formula. We have the first investment here. We don't know how much is invested initially, but this was invested under the rate of 6.78% over 12. And then to how many number of terms? 2 times 12. That is for the first 12 months then. And then the amount that you received for this investment, for this period, it is now invested further. And then with 1 plus the rate 5.2% compounded quarterly for how much now? 1.5, 1.5 year remaining, also compounded quarterly. And then we are putting this into our calculator now. And then remember now the A value for the left-hand side here, we are having 50,962.58. On the right-hand side, if you put everything into your calculator now, multiplying this bracket, you end up with 1, remember you are not allowed to round off in between your answers in finance, otherwise it's going to affect your final answer. So P, we divide both sides by this amount in order to be left with the P on the right-hand side, both sides. So this gives us how much? The 40,246.60 grade 12. And then this brings us to the end of today's presentation. And this lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Thank you very much, grade 12. See you next time.